Hello, all. Welcome to the next event of AWS User Group Punjab. This is Amandeep Singh, your organizer. Um, Today we have Aaron from the AWS Developer Advocacy team. He's a principal partner solutions architect at AWS, working with the global system integration team. He has 17 plus years of experience in distributed and embedded systems, and he has focused on integration and event-driven systems. Fun fact about him: he drives a Harley Davidson and also goes to scuba diving at weekends. Thanks, Arun. Thanks for joining us today. Over to you.
Oh, thank you very much. It's a pleasure to be here, and thank you for dropping in the fun facts. I didn't realize you were going to do that. Um, yeah, thank you for inviting me along. It's my pleasure to be here, and this is a bit of an exciting topic for me. I really enjoy coming and talking with you front end developers and or any developers for that matter. Amandeep has invited me along to come and talk about Amplify. Amplify is one of my favorite products at AWS, and also looking at Amplify from the point of view of a full stack developer, or sorry, a front end developer to enable full stack development utilizing AWS on the back end without having to have the AWS skills as infrastructure engineer or solutions architect or any of sort of the common roles that start at the back end and then move into building in the front end. So I'm not going to bother introducing myself because Amandeep has done an amazing job at introducing. So I'm going to jump straight into a quick presentation before I start getting into some hands-on coding. I want to actually code it with you live so you can see how easy it is and how it works. But first of all, before I do that, I want to give you a bit of an idea of what I'm talking about um, when it comes to Amplify and why are you here. Essentially, from my perspective, you're here because you're a front end developer and you want to learn how to take advantage of AWS as your application backend without having to learn a whole lot of new skills for infrastructure and even service configuration. So AWS Amplify is designed as the solution to be the fastest way to develop mobile and web applications that scale on top of AWS. AWS Amplify is a set of tools and services that enables mobile and web developers to build secure, scalable, full stack applications. Um, Amplify helps you get to market faster with easy to use tools and services, which include UI components, libraries, the SDKs, abstractions, and best practices built into the backend code. So today we'll take a look at some of these libraries and practices by integrating an existing React app, um, a web app in this case, into AWS Amplify and set up a supporting backend without having to know how to configure the APIs or data stores. The Amplify helps you to innovate your app with comprehensive tools and services, which support multiple web development frameworks. It has rich features and provides pretty much a one-stop shop for developing. um, Amplify helps you to perform at scale because it's built on top of AWS, which means, first of all, it's global, it's reliable, and it can scale. So let's take a quick look at Amplify a little bit closer and how Amplify services and tools help you get to market faster while focusing on innovation backend by performance. So you can get to market faster by building mobile and web applications, and also sorry into Amplify. And also we know that building mobile and web applications is hard. It's not an easy task always. So AWS Amplify leverages your existing skill set as a developer to develop Android, iOS, or web apps with use case centric features and seamless IDE integrations. Amplify also streamlines your workflow with a powerful CLI and toolchain, and that's what we're going to have a look at today. We also have the Amplify Studio, which we may look at in a future session as an additional part on top of what we do today. It also allows you to do Git-based deployments, so you can utilize Amplify's hosting environment as well as hooking into Amplify Studio to allow you to do Git-based DevOps and deployments. And with Amplify's mix and match tools, building full stack apps on AWS has never been easier. So it's a focus on innovation. The competition is never far behind. Your competition is never far behind. Amplify's wide variety of open source libraries combined with its use case based approach helps you to build features fast, allowing you to focus on your customer and the experience. So no matter how simple or complex your use case is, Amplify helps you build innovative apps and will delight your customers with the features and your unique selling point. And end users' expectations for that unique selling point are at an all-time high. With AWS best practices for security, availability, and reliability built into Amplify, your app just works. And because the Amplify CLI configures the backend for you on its own with your AWS account, you can modify individual services as you scale and expand your skills as you go. So we've designed Amplify so it's full-featured solutions. So it's a full-featured solution, across the app development lifecycle. We know app developers have intense pressure to get to market and keeping their market at a high velocity. Our goal is to make it quick and easy to incorporate a range of proven services into your applications at each stage of the development cycle. The Amplify is, as I said, a full lifecycle solution for developing, building, deploying, hosting, and even testing mobile and web applications on AWS. Amplify includes libraries, UI components, and the Amplify CLI that we'll take a look at today that integrates the backend with the most popular frameworks for building native, hybrid, web, and progressive web applications. This includes React Native, React, Angular, Vue, Ionic, other JavaScript frameworks, and tools native developers use to build native apps. And we're always adding to the range of frameworks that are supported. Amplify offers a build and hosting capabilities for web applications, including end-to-end testing as part of the build process. AWS Device Farm enables developers and Q&A to perform manual and automated tests on real devices and browsers in the cloud. And Amplify, powered by Pinpoint, offers mobile and web analytics, multi-channel messaging, that's push, SMS, email, voice, and marketing campaigns for growth and retention. So let's start to have a look at what actually is Amplify, the tools and the services. The tools and services used through the development process are made up of open source libraries for the use case functionalities with a CLI and full stack serverless hosting. Amplify offers these use case centric open source libraries, as I said before, in the Amplify framework to build cloud powered mobile and web apps. We select these use case categories since they are the most common to app development. And with these features, you can speed up your development cycle and ensure the code is valid and validated. The use case libraries and UI components are powered by AWS and work seamlessly with your existing front-end frameworks, such as React, as I said before, React Native, Angular, Vue, Ionic. Today, we're going to have a look at a React web app that I only just built a few hours before coming on. And Amplify leverages the AWS cloud to power your applications, so you get access to a far broader selection of services along with much deeper functionality within most of these services than other mobile development platforms. Amplify provides a set of features such as auth, analytics, API, and today we'll specifically be looking at GraphQL API, interactions, predictions, pub sub, storage, push notifications, XR, which is virtual reality or augmented reality, that enable you to build feature-rich serverless applications powered by AWS services. So as I said before, these are some of the frameworks that we support. We support direct Android and iOS, or native Android and iOS development, as well as React Native, Ionic for mobile. For the web, we support JavaScript, React, Angular, Vue, and others. So you can quickly add cloud services using the Amplify CLI, as the CLI is a unified toolchain to create, integrate, and manage the AWS cloud services for your app. The CLI is category based with best practices built in, and we'll have a look at this very soon in terms of the Amplify init as we step through and add Amplify to our existing app. And we're going to also use the second to the bottom one there, the Amplify add API. So let's jump in now. We'll come back to this later as we're pushing some stuff up. And I'm gonna, before I jump into Amplify, I want to take you through the app that I wrote just a couple of hours ago. So I've created a very simple app. As you can see, it's essentially it's a what do you call it? NPX create React app. So it's using the React app scaffold, and all I've added is essentially some containers, which are pages. You can see our home, admin, posts, add post, and post pages, and a blog repo. So my blog repo, I'm going to create a very simple blog with posts and comments. My blog repo at this stage is essentially just some dummy data that I've created for testing, or test data that I've created for blogs and posts. I've created a relationship between these blogs and posts by adding the blog post ID. This is the same structure that we would use for creating a DynamoDB table when using DynamoDB instead of a relational database, by creating relationships between the key value pair database or the DynamoDB database tables. And then the functions that I've created are fetch blogs, fetch posts by ID, get a post by ID, and then we've got a couple of mutations, which will be add a blog and add a post. At this stage, add a blog and add a post aren't doing anything. But if we were to, I'll run this now and show you that if we were to run this, we can fetch our blogs essentially from our route table. So if we go to the root, it'll take us to home, which is going to do a fetch from our repo for fetch blogs, then return the data, and we're just going to do a map and spit out all of our blog names essentially. So let's do a quick npm run start, and we'll just have a look at this in action. And now I have specifically left this application unstyled, so you can see it doesn't look very nice. It's just a title with some links. It's a white page. We'll go to blog 2. We can see that we've got blog 2 post 1, blog 2 post 2, blog 2 post 3. Let's go to blog 2 post 1. You can see that this is, I've just got the ID here to show you that, you know, the post ID. I actually had the same here. This is the actual blog ID. I'm putting this on the page more so for you to see how it's working, that we have an identifier here. We're using the identifier from the routing variable. We're using that routing variable to then go and pull a blog post out. I can then do the same thing. I'm using the routing variable to then pull the blog post title and description. So if we quickly jump back to our code, you can see blog post. You can see here that that's exactly what we've pulled out. So the blog ID is blog 1, blog 2, blog 3. The blog post ID is the link between our blog and what's the post. So blog 1, blog 2, blog 3. The titles are, as I said, blog 1, post 1, blog 1, post 2, and the like. And this is the post 3 content for blog 1. So you can see that we're actually pulling that data directly from our test data. So it's a very simple app. There's nothing to it except we've got a bit of a relationship between blogs and posts. At this stage, as I said, I'm showing you the posts in blog 2, and we have a little form for creating a blog post. But at this stage, it's not actually going to add to anything to the backend. If I was to just test and add comment, and if I could type correctly, I'm only going to add it to the state of the page. If I was to reload this page, it's not going to be there because it's actually not retaining it anywhere in the backend. So I'm not writing it to file, or I'm not doing anything with it in my repo. Okay, so let me just talk about the structure of this application before I get into now how do we build this out and how do we enhance this with Amplify. The structure of this application is following a very simple pattern, which is just called a service pattern or a repo pattern. This is why this is called blog repo, which allows the querying of our data to be separated from our actual application pages. So each of these pages is called a container, because the container, all it's doing is it's creating state. and retaining its state when it's loaded in. Now, if you're familiar, I assume you're probably more familiar with React than I am. I don't come from a front-end development background. I come from more of the back-end, service-oriented, and I've made my way into the front end by helping to integrate back-end through integration with front-end applications. So we follow in the back-end service-oriented architecture, or in the back-end applications that I'm used to developing, we follow patterns like Redux, which I know is available there are Redux libraries to help you build out the Redux pattern in React. We follow other repository style patterns and the like, depending on what we're doing and depending on the level of complexity that we need for the data. As well as following MVC patterns or MVVM patterns or whatever pattern you're used to. It's best to separate or segregate the responsibility between the view of the data and the accessing of the data, so the query and the mutation. So when we get into GraphQL, we're going to be looking at CQRS. So it does a separation between command and query and mutation, so which is our command query segregation principle, but it does a separation between querying and mutating. So that's making a change to our data and making a query to our data. So listing and getting, or creating or updating. So I've followed the repo pattern in this example just because it's very simple. All we need to do is instantiate our repo, and then we can start using any of the features to then pull data and supply them to the views or to the containers. So I would recommend you can start with any app that you've created, whether you're using the Redux pattern, whether you're using MVC pattern. So within your controller, I would then actually probably use a service pattern or a repo pattern with your controller, to then the controller would query in the same way that these containers are, would query the underlying service library. And then all you need to do is, whoops, I'm not looking at the service library. All you need to do is make changes to the service library to then connect to your backend. So whether you're connecting to a third-party API, whether it's Amplify, whether it's something that's on premises, it doesn't matter what it is. There's only one dependency that needs to change, which is the service file or the repo file that's connecting your application to your backend. So this, I would recommend following any data segregation pattern. Redux is my favorite, but it's up to you as the developer. I'm gonna use this blog repo as a simple demonstration of how we can now integrate Amplify without having to change our actual application itself. In part 2, we'll actually have a look at bringing in some of the Amplify UI components and adding them to our existing application. But for part 1, this is just essentially Amplify initialize and Amplify integrate. So we're going to be initializing an Amplify application into our existing React app, and then we're going to be integrating with a GraphQL API. Now on the back end, that will also create for us our DynamoDB table. I'll get into that shortly. The one thing that I will mention before we can start building our, I'm gonna stop running this for now. Before we can start building our Amplify app, is obviously you need to have your environmental prerequisites. So if you're already running React, it's likely you've already got Node.js and you've already got npm manager installed. And obviously another, if you're going to be using Git-based workflows, so committing a CI based workflow, committing to your repository and then triggering that from Amplify, you'd also need Git. But for the purposes of this demonstration, all we really need is our Node.js environment and our npm package manager. All I have installed so far is the npx create React app, which is installed the actual, obviously the testing library, but it's installed React DOM, React scripts, and Web Vitals. And then I've done an additional install of React Router DOM so that I can essentially just do some simple routing based on the URL. And that's it. So it's a very simple React app. It's the only dependencies are actually internal at the moment with React DOM talking to our container files, which again are just function-based React instead of, I prefer function instead of class, either or. If you're more familiar with using classes instead of function-based, that's fine. It won't change what we're doing because essentially we've already hooked up our repo pattern to get our data. All right, so we've got our node environment, we've got our npm packages. The next thing that we need is the actual Amplify CLI. So I spoke before when I was doing the little presentation bit about the power of the CLI, right? Being able to add workflows and being able to add user-centric components to our application through the CLI. So to get the CLI, again, it's just a node package. It's npm install, and we install the CLI globally. If you're familiar with other CLI tools, -G to install it globally, -amplify /CLI will install the Amplify CLI globally to your local environment, and then it will allow you to start using the Amplify CLI to start adding features to our application. Now, if you haven't created an Amplify application before, the very first thing that you're going to need to do, I'm not going to hit npm install because I've already installed the CLI and we would be sitting here for 10-15 minutes watching it install, and we don't want to do that. The first thing that you'll need to do before actually installing the libraries and starting to work with Amplify in your application is configure the Amplify CLI to work with your existing AWS account. So you will need to have an AWS account. If you've never worked with AWS before, you can sign up to an account. You get 12 months free. Everything that I'm doing now today would be covered under the 12-month free period. So you wouldn't be charged for the first 12 months for just building a AppSync or a GraphQL API, which uses AppSync and DynamoDB for data persistence. And to do that, you'll first of all need to have an AWS account or signed up. You just need an email address and a credit card. As I said, it's 12 months free, but you still need to have the credit card just to sign up. You just won't be billed for the first 12 months. If you already have your AWS account, the rest is easy. You do an Amplify, if I spelled it right, Amplify configure. And what this will do for you is it will ask you, first of all, what's your preferred region? And then ask you to specify a username. And then when you hit enter after the two questions, it will actually open a window in your browser to the AWS console, so you can then log in, and then it will redirect you to IAM with the wizard for creating a user with the username that you specified. So you would go through the steps. For development, very simply, I would create a administrative user, but with command line access only. So essentially, it's a full administrative access, but command line. So you're not able to log into the actual console with the user that you're creating here. And then because it's got administrative access, it has the ability to actually essentially provision anything in your AWS account. That's how I would start with development. When we get more into CI pipelines, then we remove and restrict that user. We don't want to allow programmatic access for a full administrative user across everything once we've got things up and running. So once we've started to run our application, starting to build it out and deploy it, and we want to then link it to our CI for CI/CD process, we create a Git user or if we have it externally to AWS, or a code commit user. So a code commit account inside AWS, and then you create a SSH credential for that. So it's now just using SSH to Git, and you no longer have the programmatic access to your AWS account. So it secures the AWS account, allowing you to make changes and push them into your CI. But now, because we actually want to use the Amplify CLI, we want to have that programmatic access. We want to actually deploy resources through Amplify. It's still using the AWS configuration for the profile. So go and create that user, go and get the user key and the secret key. And then the next thing that you'll do when you come back to the console is it will ask you, please provide the access key. please provide the secret key and what's the name of the profile. If you haven't already set up AWS CLI, that's essentially what it's doing. It's setting up the AWS CLI with a profile so that you can start to make requests to AWS programmatically. That's essentially it in terms of the prerequisites. Now, creating a Amplify app inside our existing app. So we've gone through all the prerequisites. We've installed all of the development environment. We've configured our Amplify configure, which also is the AWS configure for our profile, which allows us to make requests to the AWS console. Now we actually want to use the Amplify CLI to create an Amplify application. So all we do inside our application, so making sure that we're inside, I've called this application meetup, and I'm in the meetup folder, which is, as you can see, node modules, public, source, base, the root directory for our application, Amplify, Amplify, if I spell it right, init. And now I haven't already done this, so I'm actually going to step through with you of creating an actual Amplify application in our existing React application from scratch. So the Amplify CLI is smart enough to know what your environment is, what the language that you've chosen, whether it's JavaScript, TypeScript, whether we're working with React, what's the source directory path, based on doing a quick scan of your application that you're actually doing an initialize into. So the first thing it's going to ask is, what's the name of the project? And it's looking at the root level folder. I called it Meetup. So I'm going to stick with that. I'm going to say it's Meetup, and it's going to, from there, if you can see my screen, see if I can make that a little bit bigger. There we go. You can see that now it's accepted the Meetup application name as I've specified. And it's gone through and it's done that scan. As I said, it's the development environment by default. I'm using Visual Studio Code. I'm using JavaScript. It knows that I'm using the React framework. It can see that source is the path directory for the code. And then the rest, it's npm run, build, and start scripts. You can go in and modify each and every one of those properties if you wanted to change your IDE, if you wanted to change from JavaScript to TypeScript, or any other language that's supported by the Amplify SDKs for that matter. However, if you're happy with that, by default, the capitalized option is the default option. So I don't have to type Y. I can just hit enter and it will accept yes. And then it will ask me, which profile do I want to use? So the Amplify configure, before when we went and set up our profile, we can use an AWS profile, or if we've got access keys, we can use access keys directly. I'm going to use profile. I'm going to use default because that's the default one that we would have set up when we set up our environment. And now, essentially what it's doing is it's pushing through CloudFormation into Amplify and creating the bootstrap for our application. So it's going into Amplify. If we were to go into the Amplify console, I'm not going to do that this time around. We'll look at that in a future episode. But if we were to go into the Amplify console, we would see that it is provisioning an app for us, or a container in the UI, with the name of the application that we've given it and the default default settings that we've given. And that's it. There won't be any backend. There won't be anything associated with it yet because we haven't added anything. It's just going and creating that application and going and creating the base level roles and policies that are required to then start building into that application. So hopefully this will only take a few seconds so that we can get on to the next bit, which is actually starting to add here we go. Yeah, this was only a few seconds. So the first thing that I want to do is, because we've already got our app, there is nothing more that we need to do yet to add to our application other than install the dependency, the dependency library. So the actual AWS Amplify JavaScript SDK. Before I do that, I'm going to show you, we've just created this Amplify folder. So we now have in the root of our directory, root of our application, the Amplify folder. Inside this Amplify folder is actually all of the configuration that the CLI went through and created and has been pushed into the Amplify console. So all changes that we now make are now made into this Amplify configuration. before pushed into the backend, so that we can do a diff or a comparison between what are we building locally and testing locally, and then pushing into our backend as a deployment for our Amplify application. We will have a look further at this in a minute when we actually create our GraphQL API, because we'll need to go and create a model which gets pushed into Amplify, and that'll happen here in backend. All right, so next thing, as I said, was adding our AWS SDK. So npm install, and we're going to install AWS Amplify. Amplify, as long as I spelled it correctly, yes. So that's going to install into the node modules, the AWS Amplify module. And the next important thing, you will see it, hopefully, when it gets created. It may not get created. Yes. Okay, this is the one. So you'll see here the AWS exports.js. So this is the file that links your application with the AWS Amplify backend. Now, we haven't actually created anything yet, except for as part of our configuration, I set my default region, which is AP Southeast 2. So it's created the Amplify app in the console in the AP Southeast 2 region. That's it. That's all we have at the moment, is this configuration. But as we start to add our backend, it will go and add more configuration to this file, and this is what links the two, and I'll show you very shortly how we link them. Links the configuration of our Amplify app with our existing React app. So what I'm going to do is, instead of, if you were to follow some of the online tutorials for getting started with Amplify, it's going to ask you to add everything here in the app. But because we want to maintain the segregation between our backend and our application that we've already created, I'm not going to do that. What I'm going to do is, I'm going to do everything inside my service app, the blog repo. So the first thing that I want to do is import Amplify from AWS Amplify. So we now have our Amplify library. The next thing that we want to do is import that exports folder. So AWS exports, oops, if I spell import correctly, from, now that's going to be back one and AWS exports. So we now have the Amplify library and the Amplify exports folder. And then to tie the two together, it's amplify.configure. And we just drop AWS export in there. That's it. So we've now tied together, as we develop our application backend, and it ties, we add additional resources, it will give the Amplify libraries the configuration that it needs based on the endpoints, based on the authentication, based on the region and everything that's set throughout the CLI into the AWS exports, and then linked to our Amplify library through the Amplify configure. So when we initialize our application, it loads in all of the backend requirements or the backend integration into the library, so we can start using the library now to start integrate or connecting to our backend. So the next thing that we want to do is, I'm just going to do a quick sound check just to make sure I can still hear everyone. Yep. Okay. So the next thing that we're going to do is we're going to add our Amplify API. So we're going to go and add a GraphQL API. Adding GraphQL or REST is the same. We use the same command, and it's as simple as this. So we're using the Amplify CLI. It's Amplify, add API. As simple as that, right? But now it's going to go through and it's going to ask us a series of questions. So what do we want? Do we want REST? Do we want GraphQL? At the moment, we want GraphQL. At the moment, we're going to do, so for this session, we're going to do just a basic authentication mode. So it's going to use an API key. The API key will be added to the exports file, so we don't actually have to do anything, add it anywhere, add it to a header, to set up our query to the AppSync endpoint, it's going to add it to the exports for us. So all we need to do is call the library, and it will talk. In a future episode, we're going to have a look at authentication, and we will change how we access this. We're going to build off of this app. We'll change how we access this by using the authentication, using Cognito for authentication, and then using that JWT token to then authenticate with the endpoint that we query. But for now, we'll just use the API key. And okay, I usually create. So usually I start with either a one-to-many or a single relationship based on whether I'm going to do something simple. We're going to start with a blank schema. Just because I want to run you through some of the simple things that we need to know about GraphQL. If you've never worked with GraphQL, this will help with learning how to develop a GraphQL schema, which is the important part around creating your data structures. So that I will do from scratch. If I was to just drop something in there so you could see it, I don't think we would learn. So do you want to edit your schema now? We click yes. Now it's smart enough to know that we selected public, so it's using the API key for authentication. So it has already added for us the input amplify global auth rule and public. So it's allowing, essentially, it's allowing anyone to access this API that we're about to create without having authenticated. So that's okay for like viewing posts that are public, but we might not want to allow people to edit posts, create posts, and that sort of thing. So for today, that's fine. It'll all be public, but in the future episode, we'll also look at RBAC. So the actual role-based access control. So how can we stop people from editing other people's posts? How can we stop people from creating a post if they're not authenticated? And how can we allow public users to view our posts? But we'll do that all through the GraphQL model. So we won't have to interact with anything else. We just create the RBAC control in the model itself. But for now, we're going to create our blogs, posts, and comments. I haven't actually added comments, but we're going to leave it there because I want to add to it later where we will allow people to add a comment to a post that they're not allowed to edit. So I want to show you the difference between working in with query and mutation of using those RBAC controls to allow querying and mutation of different role groups and having different permissions across different models. So for now, let's go and create our GraphQL schema. So it's as simple as this, right? The first thing we want to do is we want to create a type. So a type is just like you're used to with JavaScript. Your types are your object variables, right? It's an object. So it's not a primitive type like a string or a number or an integer. It's now a class that we're creating. So we're going to create our blog. And one of the important things here for linking from AppSync to DynamoDB is if we call this a model, it's actually going to go and create a DynamoDB table for us. So we've just used this model keyword, and that's all we need to do. So AppSync will take the GraphQL schema and look at the model keyword, the app model keyword, and say, all right, this type must be created as a DynamoDB table. Now, there are other ways of creating types without creating DynamoDB tables, and we can look at that in a future episode. But for now, we're just going to create every type as a DynamoDB table. The most important thing for any table or any type is an ID. So the first thing we want to do is we want to give it an ID, and we're going to say that this ID is not nullable. So the exclamation means that it's important, it's not nullable. So our ID is non-nullable. We're going to give our blog a name, and we're going to just make it a primitive, so it's a string, and also it's not nullable. It must have a value. And then finally, actually for now, I'll leave it as that. Then we're going to go and create our posts. So for our blog, we want to have posts. So we go and create our new type. It is a post. Again, it's a model. Again, the most important thing is it has an ID. So it's an ID type and it's not nullable. We'll give it a title. Again, primitive string, not nullable. And obviously we want some sort of content. And we'll just make that a string and not nullable. So everything essentially we need to have a value if we're going to create a post. And then what we also want to do is we want to link post to blog. So we want to create a relationship. Now, yes, it's a key value pair table, so it's a DynamoDB table, but we can create relationships through tables using the GraphQL modeling. So what we can do here is we'll say that this post belongs to a blog. But the important thing here is we're using the blog type as its type, but beyond that, we're adding the keyword belongs to. So this now says that it has a relationship with the blog type model. And we need to do the model relationship back the other way as well to say that the blog has many posts. So it's posts, posts, and it's of type post, but it needs to be an array. So it's many. So we use the array posts. And again, we use another identifier to say has many. So this is the relationship type. Posts belong to blog, and blog has many posts. So while it is an array, it also helps to have the has many to represent a relationship as opposed to just an array property. Now, the final one that we'll add is comments. We're not going to use comments today, but we're going to add it there anyway. So we're going to create a comment type. Again, it's a model. So we have the DynamoDB table. Again, the most important property is ID, not nullable. Post is, content, because it's going to be a comment. So we want to have some content for that comment. It's going to be a string. Again, not nullable. And now we want to do the same thing that we did with blog and post. We want to add comments to posts. So we'll say post, it's one post, and it's a of type post, and it belongs to. And then equally, we need to do the same thing for post, and that's comments. And it's an array of comment now that we've created it, and it has many. And that's it. That is our GraphQL model that will be used today. Yeah, go for it.
Small typo on line number 19.
Line number 19, type comnet. Thank you very much. That would have created a failure because I'm trying to add a comment type when the type name was comnet. Thank you very much for picking that up. We probably would have got to the point of trying to debug why we weren't having a list of comnets on our comments array. So that saved us some trouble probably for episode 2. That's it. So we have a blog that has an ID and a name, and it has many posts. We have a post that has an ID, a title, and content. It belongs to a blog, and it has many comments. We have a comment that has an ID and it has content, and it belongs to a post. That's it. So the next thing that we want to do is actually push that. So we want to now provision this model as an AppSync service with our DynamoDB backend. So essentially, it's as easy as we've created our schema. We say amplify, push. Now it's going to quickly do a check. It'll do a difference between what we've got on this side, and it'll do a check on what we've got on the back end, and it can see that we are creating a new API for the Meetup application. And are you sure you want to continue? Yes, we do. So it's now going to go through and provision our GraphQL API as an AppSync service. backed by three tables in DynamoDB for post, comment, and blog. Now, while it's provisioning there, that's going to take a few minutes. I'm going to jump back to the presentation that I had before, and I'm going to quickly run through, because we're looking at integration and APIs, I'm going to run through the actual API architecture that we have in Amplify. So now you have a bit of an idea of how API connects to data and to your application. It's essentially done through an API layer. So we have two types of API services. We have essentially the API gateway, which is our REST API, and we have the AppSync, which is our GraphQL API. So you can take advantage of Amplify's libraries to get started on either type, REST or GraphQL. Essentially, I want to have a look at the differences, why you would choose one over the other. So why would you use REST over GraphQL or vice versa? So the benefit is that you're making a single request with GraphQL. Over REST, you have to do, say, 3 separate requests. So we're looking at REST over on the left. We will make multiple requests to get a post author, post by title, post info, post themselves. Whereas we could create a query which provided all of the different resources or all of the different data, which could be across different tables, into one model. So on the right hand side here, we're looking at a bucket, a lambda, a table. We can essentially create multiple resolvers to return multiple different data sources into a single model via a single query. So we essentially are making a post request to AppSync saying, this is the data that I want you to populate. Go and use the resolvers in the backend that we've set up to populate it and hand back a single response. So essentially with GraphQL, you only have one endpoint and only need to make one single API call. The data is retrieved from those multiple data sources automatically. And these data sources can be anything, essentially. You can use SQL, NoSQL. It can be other HTTP endpoints. So essentially, if you wanted to, you could have a GraphQL API calling a REST API as one of your data sources under the hood. So GraphQL API allows you to cover a lot of different data sources from one single point of access, as opposed to multiple different data sources like we have on the REST side, which may be coming from multiple different resources. So in this case, REST endpoint / post, REST endpoint / comments, REST endpoint / authors, as opposed to getting post, comments, and authors from a single endpoint resource. And then also on the back end, post, comments, and authors may be coming from different databases or data sources. I should have been clicking as I was talking. And what we're going to take a look at very shortly is now in our repo, how to actually use the Amplify API libraries to actually go and do our GraphQL query without having to write out the queries ourselves. So I will jump back over here. Do you want to generate code for your newly created GraphQL API? Yes, I do. So what it's going to do for us now is we want it in JavaScript. I'm going to leave it in the root of source. So generally, if I'm working with services, I'd have it created under services, but for the simplicity here, I want to show you the defaults. So it's going to create our queries and mutations and subscriptions in the root of the source of our application. And we want to generate all possible. Yes, please. And we want to go to a depth of 2 for this stage. So what this is doing now is it's creating for us all of the possible GraphQL queries that we could make. So whether they're queries or mutations based on the actual model that we've created. So it knows that we've got models that have a list of posts that have a list of comments. It knows the properties. It's going to go through and it's going to create our list all, get all of the essentially queries and mutations that we could create. That we would create if we were not using the Amplify library to go and talk to our API endpoint. So this simplifies things by reading our model. It's not only created the backend for us, the AppSync, GraphQL service and the backing DynamoDB tables, but now it's generating the actual queries we need for the GraphQL query, so that we don't have to do that work ourselves. So it becomes very easy for us to now, I'm going to close, well, I'll leave it there. Let's go back over to our blog here. It becomes very easy for us to now start to integrate by adding the libraries that we've installed. So we've installed the Amplify library into our graph, into our what's it called? The blog repo is the word I'm looking for. So we want to go and add essentially the two bits that we need are we're using the Amplify library. So actually, let's pull this out. No, we can leave that there. We're using the Amplify library. We also want to use the API library or the API SDK and the GraphQL operation. So the GraphQL operation is the important one. So we can, if we wanted to, use API and build out our queries from scratch. So if we wanted to create a query that maybe the auto-generated code didn't create, we can still do that. But by using GraphQL operation library, we can use that to then build out the queries for us using the generated code. So it just makes things so much easier instead of having to build everything from scratch. I am still waiting for the code to be generated. So the next bit, I'm going to have to wait a few seconds. But essentially, the hard work is done for us. All we need to do next is actually import the actual generated code that's being generated right now to start working with our backend. So I'm going to run through this. I believe I've only got about 10 minutes to go. So I'm going to run through adding everything very quickly instead of trying to explain things as I go. I'll mention a few things, but I want to try and get it there so I can demo to you that it's working without missing anything in the next 10 minutes. So the first thing I'm going to do is I'm going to import the list blogs and list posts, and I will also import the get post and the create blog and create post. So these are the only features that I've created in my application so far based on the existing functionality that we created just with our test data. So I'm going to start writing the import even though the code isn't there to import from yet. So we'll get to that when it gets there. So import, we want list blogs. It's going to be list blogs, list posts. It's not capitalized. List posts. That's all we need for now. That will come from the library once it's generated. I will also import get post. And then I will also import create log and create post. So these are our libraries that we're going to be using. They will be generated for us. I'll look at that soon. For now, I'll say from, just so that it works. All right, so that's going to pull from, eventually when it's there, it should be GraphQL queries. This one will also be GraphQL queries, and this one will be mutations. Oh, I think the only one thing we need to make sure is that that's above that. You can't do an import after a function call. All right, so now we have, there we go. So the GraphQL folder has been created. Everything's finished. So we have a queries file, we have a mutations file. I'll quickly jump in there. You can see get blog. This is the structure of a GraphQL query. So this can be quite confusing if you've never looked or worked with GraphQL before. List blogs, so we can filter at the next token if we're actually doing a paged query. And then we have filters so that we can filter on how we want to, or what we want to filter out for our query. Get post, list posts, same for get comment and list comments. And then our mutations are create blog, update blog, delete blog, create post. The same for post and comments. So what I've done is I have imported list blogs, list posts, get post, create blog, and create post from our queries and mutations. Now all I'm going to do is I'm going to start swapping out everything for our, so instead of using our test data, what I will do is I'll say const blog query equals await. So we're going to use the API library that we imported. It's the GraphQL API, not the REST API. And we're going to use the GraphQL operation instead of creating the query ourselves. And we're just going to use the list blogs that we just imported up here. So the list blogs that's come from our generated code. List blogs. Then from that, the important thing to remember is const. Oops. Logs equals log query. So the actual data that gets returned comes in a packet, right? So the packet is, or an envelope. It's in a data envelope, and it's always named the name of the query that we've sent. So the data envelope will be list blogs, and then it's items. It's an array, so we say items, and that will give us all of the items from the list blogs query into this object here, and we can hand it back. So that, if we go and get rid of this, will now allow us to query blogs and return blogs. I will quickly just go and add, I've got 4 minutes, I believe, so I'm going to go and add the same for const post query GraphQL. We're using our GraphQL operation. This time it's going to be list posts. Okay, now we also want to do list posts based on blog ID. So what we're doing is we're actually going to specify whoops, you saw it for a second there. We're going to specify a variable that it uses for querying. So we'll say the variable will be blog post ID. So that's when you create a relationship, it automatically creates the blog post between the two objects. It joins them together, and it's the ID for the blog post object. So we're going to call it blog post ID, and we just need to give it ID that we're handing into our function. And we can the same thing for posts. We say posts const posts equals post query. So it's in a data object. It's called list posts this time, and it's still items because it's still an array. Then we can get rid of our filter from our test data. So let's get rid of our test data. Now, finally, getting a post. So post no longer exists. So we will say for getting a post, we will, where do we go? Get post, const post query equals await API GraphQL operation. This time it's going to be our get post, and the parameter this time is we just want to filter on the actual ID of the object. So that's simple as ID. Done. And because this is a single object, this time const post equals post query. It's just the data envelope is just the name of the query. So that'll be get post. So we can now return post. So that will return the post of the post that we're looking for. Now the mutations, we actually, it's as simple as wait. We do the same thing. So we're just doing API GraphQL. It's still a GraphQL operation because we've had the autocode generated, and it's going to be create blog. And this time our argument is actually going to be input. So what is the input is the actual blog object. So we're going to hand the blog object from our form that I'll quickly jump over to. And that's it. I'm done. I don't actually have to do anything more than that to now go and create the blog post and persist it in the backend. Sorry, yeah, the blog and then the post, exactly the same thing. So let's just copy this and change this to create post, and the input this time will be post. I have now, that's done. I've now hooked up my Amplify Amplify library with the endpoint. So if we go back over to exports, we can see the endpoint has been added. All of the information for our API key is there, so it will do the query for us. We've pulled the API library so that we can do a GraphQL query. We're using the GraphQL operation so that we can then use our generated queries that we're now importing, list blog, list posts, and you can see here it's query get post. You can see it in the string there. So all we do is our blogger operation, and we add it to our GraphQL query, and it'll do everything for us. And then let's run it. So I'm done. npm run start. Hopefully, I haven't created any syntax errors, and it'll just build, and everything will be happy. So now we can see this run again. But as that's doing that, I'm going to go over to the admin page, because remember I created the form. I just want to quickly show you all the form is doing is I have a form state. I'm doing the fetch blogs, so we'll be able to see when we go to the admin page that there are a list of blogs. So it's doing a fetch to our repo. It's querying the blogs, and then it's setting the state of the return data. If there's no data, it's just adding an empty array, because that's just a failover that I always seem to add for redundancy or for OCD. Essentially, all I'm doing for when I post or want to create a blog is in my form. I have the set input on change. It's just a single function. Just makes it easier instead of creating one for every different field. It's just updating the form state. So it's using set form from the use form state. It's breaking out the existing form state, if there were any, and then adding the value to the key based on the key value that I hand from the actual input. It would be the same for, let's go over to add post. Now you can see form state, same set form, but now we actually have two inputs. It's still using the same. So we're specifying what is the key and the value that we want based on the actual input that we're using. So let's quickly jump over to the app. We have no logs because there's nothing in our database. So let's go and create a AWS user group blog. Or let's just call it AWS user group. Create blog. You can now see that that's in our list here. But let's actually go back to our home. We can see our AWS user group blog. Let's go in there. This is the ID. Remember I said I wanted to show you the ID just for functional purposes. You can see the ID that's auto-generated for you when you create a blog post. The same thing will happen now when we create a post. So this is my Punjab user group demo, and this was a fun demo of GraphQL in Amplify. Create post. So that's using the blog post. We're actually submitting the, if we go to add post, we're actually submitting the blog post ID as a part of the post. So all we're doing is we're taking the form state, title, content. It's just a simple object. If we have a look at the initial state here, title, content, adding to it the blog post ID for the current blog that we're in, and then submitting it to our repo, the add post function, which is just doing our GraphQL operation for create post and handing that object in as the input. Very simple. And we now have, back to our app over here, that was our old one, the new one over here. We now have a blog post here. If we go back to the blog, something went wrong. User group demo. You can see that it added to Okay, here we go. Each child in a list should have a key. All right, what am I missing? Here we go. Key item dot ID. Let's rerun that. User group demo. It was fun. Create. Still the same problem on add post. Where are we at? Maybe that didn't reload. We have a key for posts. Yeah, something not happy with that. I will have to debug that later, but essentially you can see how we're now we've created our blog at least, so we can go and create more blogs if we wanted to. If we go back to home, if we went to admin, we could create another blog that's doing the same thing. I probably just missed something on the other page. So second blog, so that's got more to do with my front end than it does about the back end. So it is actually submitting the actual data into DynamoDB through our GraphQL query. So that's it. That's the basics of initializing a Amplify app into an existing React app and adding a GraphQL API backed by DynamoDB and integrating it through a repo pattern into our application.
Thanks, Aaron. That was fun. Thanks for this knowledgeable session. And thanks everyone for joining. We would hopefully learn a lot more about Amplify in upcoming sessions from Aaron. So stay tuned. Thanks, Aaron.
Thank you all.